Okay, so let's get started quickly. Today is, well, it's 1st July for you. Okay, so Anika, today we'll begin with a hack, and this hack will actually allow you to find out the center and radius of any circle without completing the square. Okay, so see, whenever you have an equation of a circle in expanded form, like for example, if you have equation in this form, x square minus 8x plus y square, and let's say plus 25y plus 37 is equal to 0. This right now, this is expanded form of the equation. And the how do we get from expanded form to the standard form?
Complete the square.
Completing the square, yes. So you know how to do that now. So you'll do plus 4 and minus 4, and this shouldn't be 25, this should be 10 y. Then you divide 10 by 2, you get 5. 5 square is 25. You add and subtract 25. So finally you'll get x minus 4 whole square plus y uh, plus 5 whole square, and when you do all the calculations you will get this is equal to 4. Okay, so you'll be doing completing the square to convert the expanded form to the standard form, right? But with this hack you can directly get the center and the radius. First of all, Anika, can you tell me what is the center and the radius?
Would the center be 4 comma negative 5?
Yes, center is 4 comma negative 5. And what is the radius?
2?
2. Perfect. Now you can get this center and the radius without converting the equation into the standard form, without doing this step. Just by looking at the expanded form you can directly tell these coordinates. Okay, so the shortcut for that is, first of all you will compare this equation with the general form of the equation. So it is given by x square plus 2gx plus y square plus 2fy plus c is equal to 0. Did I tell you about this shortcut?
Uh, maybe.
I think
Just wait.
I don't remember that I told you about this shortcut. Okay, so now Anika, you have to compare this white equation with the yellow equation. Okay, and all you have to do is just find out the values of G, F and C. G, F and C. So can you tell me what is the value of G, what is the value of F, and what is the value of C by comparing?
So G would be negative 4.
Perfect,
Then F would be 5.
perfect,
And C would be 37.
perfect. And now when you have the values of G, F and C, then in order to find out the center, your center is actually negative G comma negative F, and your radius is square root of G square plus F square minus C. Okay, so negative G comma negative F, that means negative of negative 4, that means positive 4, and negative of F, that means negative of 5, that will be negative 5. And your radius is gonna be square root of G square plus F square minus C. So G square means negative 4 square, that is 16, f square 5 square, that is 25, minus 37. 16 plus 25 is going to be 41. 41 minus 37 will be 4. Square root of 4 will be 2. Okay,
Okay.
did you understand this method?
Yes.
So you need to remember this equation, x square plus 2gx plus y square plus 2fy plus c. Also, what you can do is, even if you don't remember this equation, just do one thing. If you have your equation x square minus 8x plus y square plus 10y plus 37 is equal to 0, just look at the x term and look at the y term and look at the constant. For the x term, divide the coefficient by 2. So divide negative 8 by 2 to get negative 4. Okay, and divide the y term by 2 to get 5. Right, so that becomes your center, negative 4 comma 5. I mean, sorry, now you have to take its negative. So negative of negative 4 is 4 and negative of 5 is negative 5. So all you have to do is divide the coefficients of x term and y term by 2, right, and then take its negative. So that will be your center, and for radius you just use this formula, g square plus f square minus c. Okay, that will save a lot of your time.
I think uh I think you briefly went over it the last time we had class.
Yes, because I remember that I think I told you about this hack, but it's okay.
Mhm.
So in the questions, I want you to use this method only, okay? Don't use completing the square, because completing the square method takes a lot of time. This will give you, and completing the square method has also scope of making a mistake. It involves a lot of calculations and a lot of steps. Okay, so now Anika, we have to do a couple of theorems. Today we'll be doing some theorems. Okay, so I think I should have told you about this in the first class. Not here. Anyway, so in circles, Anika, the most important topic is equations of circles. You will definitely get one question from equations of circles. The second most important topic is arc length and sector of the area, and the third topic is theorem. So there are less chances that you'll get a question from this topic directly, the topic that we're going to do today, but still you should know all the concepts. We never know, you can get a question from anything, and circles itself is a really important topic for SAT math. Okay, so Anika, today we are going to do a couple of theorems. In the next 10 minutes we'll try to complete them. So first two theorems are based on tangents. Anika, do you know what is a tangent?
Uh yes, it's like a line that touches a circle or like the edge of
Exactly.
a circle, curve of a circle.
Yes, exactly. So it's a line that touches the circle. Now this theorem says that every tangent is, let me change the color, every tangent is perpendicular to the radius at the point of tangency. So the point of tangency is this. So the point at which the tangent is touching the circle, that point is called the point of tangency.
Miss Linda, just give me a second. I'm just going to blow my nose.
Okay, sure.
Thank you.
you back? Okay.
Yes. Thank you.
Alright, so yeah, so the first theorem tells us that every tangent is perpendicular to the radius at the point of tangency. So the point of tangency is that point at which the tangent is touching the circle. So this is the point of tangency. Now if I draw the radius at this point, Anika, so if I draw a radius at this point, so let's say that this is going to be the radius and this is the center of the circle. So this tangent is perpendicular to this radius. That means this angle
So
is going to be
90
a
degree
right.
angle.
Yes, exactly. Okay, so that's what this theorem tells us. So every tangent is perpendicular to the radius at the point of tangency. That's the first theorem on tangents. And the second theorem is that if you draw two tangents from the same external point, so here let's say that this is an external point called P, and I have drawn two tangents from this point to the circle, and this tangent is touching the circle at this point. Let's say this point is A, and let's say that, so this point is A and this point is B. So whenever you draw two tangents from the same external point, then these two tangents will be congruent. So now the tangent PA will be congruent to tangent PB. So PA will be congruent to PB. That means if the length of the line segment PA is 12 centimeters, then the length of the line segment PB will also be 12 centimeters. Okay.
Okay.
So two tangents drawn from the same external point will be congruent, and here PA is congruent to PB. Okay, so now I'm gonna give you a practice questions based on this concept. Let's say we have a circle. Okay, I think we did this question in the first class. I remember doing one question. Yeah, this one. If you remember, we did this question, and in this question we used the second actually, yeah, we used the first theorem in this one. If you remember, we used the first theorem. I gave you this question and then I told you that whenever you draw a tangent, it is perpendicular to the radius, and that's why we got this angle as 90 degrees and this angle as 90 degrees. You remember this?
Yes.
Okay, now I'll give you one question. Oops. Let's say, okay, so let's say that you have this circle. Anika, do you, okay, I'll ask that question later. So let's say that we have this circle and we have these two tangents, and this is the center of the circle. Okay, and this is a line, this is the radius of the circle. Okay,
Yes.
and we have this point as O, this point is A, this point is P, this point is B, and this length is, let's say, 12 centimeters, and let's say that this angle is 25 degrees. Okay, so you have to find out three values, Anika. First you have to find out the measurement of angle POA. Second, what will be the length of the line segment PB, and third, what will be the length of the line segment OA, or the radius.
So so mhm.
So first try to do the second part, PB. What will be the length of the line segment PB?
So PB, wouldn't it be 12?
Yes, exactly. That's going to be 12. That's exactly what we did in the second theorem, right? The two tangents will have same length, so this is going to be 12. Now
And
let's try to do the first part.
would
Angle,
that be 65 degrees?
perfect. That's going to be 65 degrees. And how did you get it?
Well, because it's like a tangent intersecting with a radius, and that lets me know that the other angle will be a 90 degrees angle. And so from that, I can figure out the missing angle.
Perfect. So we have the first part and we have the second part, and now for the third part, OA. We have to find out OA. Let's say that this is X. Now in this one, how can we find out the length of the radius? I'll give you a hint. The hint is trigonometry. You have a right triangle. POA is a right triangle, and you know this side 12 centimeters, and you have X. So try to think about which trigonometry ratio you can use to find out this length.
Isn't there um 60 or not 60?
You want to use this angle? So you have both the angles. You have 25, this is 90, this is 65, and you know that this length is 12 centimeters, and you want to find out this length. I've just drawn this triangle, so that things become clear. So first of all, Anika, tell me, have you completed trigonometry?
Uh, well, I learned trigonometry, yes.
Okay, so do you remember the three ratios, sine and cosine and tangent?
Yes.
Okay, so
So, sine is opposite over hypotenuse.
yeah, opposite over hypotenuse. Cosine,
Adjacent over hypotenuse.
hmm,
And then, tan is, uh, opposite over adjacent.
yes. So there is a mnemonic to remember these ratios. SOHCAHTOA. So sorry, so ka toa. SOHCAHTOA. Have you heard of this? SOHCAHTOA.
Yes.
So sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and toa, tangent, is equal to opposite. So perfect. Now you have to find out this length and you know this length, and this is, now if you consider this angle 25 degrees angle, so this is your opposite and this is your adjacent. So which trigonometry ratio you can use if you're considering this angle 25 degrees angle?
25 degrees angle, then couldn't I use cosine?
No, but with respect to this angle, this side is the opposite, right? And this side is the adjacent. So we have to use these two side lengths, right? We have to use
Okay.
tangent, yes. So you will write that tangent of 25 degrees is equal to opposite over adjacent, right? Because opposite is what you need to find out, so x, and adjacent you know already, it's 12. And tangent of 25 degrees, you can use your calculator to find that out. You'll have your calculator, you find out what is tangent of 25 and you write whatever that here, then you multiply that by 12 and you'll get the value of x. Okay,
Okay.
now again I want to mention this, that on SAT math you will not get, there are, they try to club two concepts in one question. For example, in this question they have clubbed the concept of circles and the concept of trigonometry. And whenever you see a right triangle and you feel stuck, then the chances are that you will have to use either trigonometry or the Pythagorean theorem.
Okay.
Okay, so these were two theorems on tangents. Now we will do inscribed angles theorems. Inscribed angles theorems. So there are three inscribed angles theorems. First circle, second circle, and third circle. There are three inscribed angles theorems. The first one, which is the most important, Anika, that is called that the angle in a semicircle is a right angle. Now here I have a circle. If I divide this circle into two equal halves, so this is a diameter, and a diameter divides the circle into two equal halves. Now if I draw any angle inside this circle, so let's say this is one angle, and let's say if I draw another angle and I draw another angle, all these three angles will be right angles. Okay, so this is gonna be 90, this is gonna be 90, and this is also gonna be 90. Okay, this theorem says that angles in a semicircle are right angles. Okay,
Okay.
okay, then the next theorem says that if I take an arc, I'm taking one arc, and if this arc subtends some angles, now let's say that it subtends this angle, this is one angle that it is subtending. Now let's say it subtends another angle, this, let's say it subtends another angle, this, any angle it subtends on the remaining portion of the circle. Okay, on the remaining portion of the circle, let's say one more, I'll take one more angle. The blue color is not visible, let me take red. Okay, any angle on the remaining portion of the circle, then all these angles will be congruent. Okay, all of these angles will be congruent. So If this is 20 degrees, then this will be 20 degrees, then this will be also 20 degrees, and this will be also 20 degrees. So if this is x, this will be x, this will be x, and this will be x. Okay, so
Okay.
this theorem says that angles subtended by the same arc are congruent. Okay, that's the second theorem. And the third theorem says that, again I will take an arc. Again, let's take an arc. Now I have this arc, Anika, and this arc is subtending, let's say it is subtending an angle on any part of the circle, and if it is subtending, it is also subtending an angle at the center of the circle. Okay, at the center of the circle. Then this angle which is at the center of the circle will be twice of this white angle. So this red angle will be twice of the white angle. Okay, so if this is x, the white angle is x, and if the red angle is y, then we will say that y will be twice of x. So if x is 30 degrees, if x is 30 degrees, then y will be 60 degrees. Okay?
Yes. So,
You want to ask something?
uh, no. I think. Actually, can you explain it again, please?
Which one? The third one?
Good one.
So it says that if you have an arc, so this is an arc,
Yes.
okay? Now if this arc subtends an angle at the boundary of the circle, okay? And if the same arc is subtending an angle at the center of the circle, right? It has to be the same arc. So a same arc is subtending the angle at any point on the circle, and it is also subtending an angle at the center of the circle. Then the angle which is at the center which be twice of the angle which is at the boundary.
Okay.
Okay, so if this angle is 30 degrees, the one which is at the boundary, then the central angle will be 60 degrees. It will be twice of that angle. Okay,
Okay.
and we will do one more concept. Wait, Anika, I think I'm not getting all the tools. I need to close this and I need to open it again. Yeah, the last concept that I want to tell you is the concept of cyclic quadrilaterals. So Anika, there is a thing called cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral whose all the four vertices lie on the boundary of the circle. So if you have a quadrilateral like this, it will be completely inside the circle, and all the four vertices A, B, C, D So the four vertices of the quadrilateral lie on the boundary of the circle, right? A, B, C, D. So this A, B, C, D is a cyclic quadrilateral. What is it?
Cyclic quadrilateral.
Cyclic quadrilateral. Now a cyclic quadrilateral is a special quadrilateral. It follows some properties. In a cyclic quadrilateral, the opposite angles are supplementary. Anika, do you know what are supplementary angles?
Does that mean like when added together it creates like
Yeah,
180 or 90?
180. Yes, supplementary angles are when you add them, they are equal to 180 degrees, and complementary angles are when you add them you get 90 degrees. So in cyclic quadrilateral, opposite angles of a cyclic quadrilateral are supplementary. You should know supplementary means 180 and complementary means 90. Okay,
Okay.
supplementary means when you add two angles they will add up to 180, and complementary means 90. So this means that here angle A plus angle C will be equal to 180 degrees, and angle B plus angle D will be equal to 180 degrees because they are the opposite angles. Okay, today we won't be able to do practice questions on these topics because now I want to review the questions from the previous class, but today I will be sending you an assignment on these theorems that we did today, right? the
Yes.
the two theorems on tangents and the three theorems on inscribed angles
This.
and cyclic quadrilateral.
Okay.
Okay, now let's review the assignments. Okay, so here in these questions, wait, in the second question the area is given. Okay, let's first talk about the first question, Anika. In the first question it says that the length of the arc AB. So this little, sorry, let me change the color to red. This little symbol that you see on AB, this little symbol, this means that they're talking about the arc AB, this symbol. Okay, so the length of the arc AB is pi, so this is pi. What is the area of sector OAB? Now in this case, as I told you, they will not give you the angle and the radius directly, because if you know the angle and the radius directly, anybody can find out the sector area or the length of the arc.
Yes.
So they will not give you all the information directly, but they will give you some other information. Here they have given you the angle. They have given you the angle. We need to find out the radius, right?
Yes.
Okay. Now they have not given us the radius, but they have given us some other information, which is the length of the arc. The length of the arc AB is pi. By using this information, we will have to find out the radius. Okay,
Okay.
so this is a very common type of question that you can expect on the SAT math. In fact, this is, I think, some previous year question only. So Anika, you know the length of the arc. What is the formula for length of the arc?
For length of the arc, arc it has to be um so the central angle over 360 by the circumference.
Perfect. So central angle is 36 over 360 times the circumference.
To find the circumference,
Hmm.
would I have to multiply pi by 10? Or
No, first we will just set up the equation. So you said that it is given by central angle divided by 360 times 2 pi r. So 2 pi r, we don't know what is radius, right?
Mm-hmm.
Now this is what? This is your arc length, right?
Mm-hmm.
And they have given us the arc length, which is pi units. So in place of arc length, I can just write pi. Pi is equal to 36 over 360 times 2 pi r. Is this step clear, Anika?
Yes.
Right? We don't know the radius, but we know the arc length. So I put this formula and I put it equal to pi because they have given us the arc length. Now this is a simple linear equation in one variable. The variable is r. Can you find out the value of r by solving this equation?
Um. So would I first divide both sides by pi?
Yes, divide both sides by pi.
And so that way I'd be able to multiply the 2 by 36 over 360.
Yes, you can do that, or I'll tell you some steps. You are absolutely correct, but I'll tell you some steps which will, reduce your calculations. Okay, so first of all, this is 36 over 360 here. You can simply simplify this, so this goes 10 times. 36 times 10 will be 360.
So it'd be 1 over 10.
That is 1 over 10. And then you have this 2, so 10
It
again
would be
goes 5 times.
so 1 over 5.
1 over 5. And when you have pi on both the sides, like you have it on the left hand side, you also have it on the right hand side, and it is in the numerator. Pi is here in the numerator, it's here in the numerator. So you can divide the equation by pi, then it will get cancelled from both the sides. It will just become 1 when you divide the equation by pi. So you'll be just left with 1 is equal to 1 over 5 times r.
So 1 is equal to. Oh, so that means r would be equal to 5.
R will be equal to 5. Okay, so you should be actually able to do these calculations inside your head. You should not even need to pick up your pen to do these calculations. How will you do these calculations in your head? Let's do it again. So we have pi is equal to 36 over 360 times 2 times pi times r. The less you will use your pen, the faster you will do your calculations. The more you will use your pen, the more time it will take. So try to do the calculations in your head. Okay, so you have to think like this. 36 over 360 will give me 1 over 10. Then 2 over 10 will give me 1 over 5. Then if I divide this equation by pi, pi will get cancelled. So I'll be left with 1 over 5 times r, and then r will
And
be equal to 5.
r would be 5.
So it will take some time. Initially you might make some mistake when you're doing calculations in your head, but eventually you have to come to that stage that you should use your pen as less as possible. Okay,
Okay.
so just after this step you get your radius as 5 units.
So the answer would be B, I think.
B. Okay, I don't know the answer, so answer will be uh, 36 and 110 times pi r square. Pi r square 25, so 5552. Yes, so the answer will be B. Okay, now
Okay.
you can expect a lot of questions like this. Now they could have framed this question like this as well, that let's say that the area of this sector area, they will give you the area. It is 5 over 2 pi and the angle is given, and you have to find out the length of the arc. Okay, the opposite. Right now the arc length was given and we found out the area, but they could also give you the area, and now from area you will find out the radius. So how will you find out the radius from the area? You know that the area is given by 36 over 360 times pi r square, and this is given to us as 5 over 2 pi. Okay, so again you will simplify this. This will be 1/10. This will be 1/10. Pi will get cancelled from both the sides, and you just cross multiply. 5 over 2 times 10 over 1, this is equal to r square. So what did I do? I multiplied both the sides by 10. This times 10 and this times 10. So 10. So from the right hand side 10 gets cancelled. Now this is gets cancelled. So 5 times 5, 25 is equal to r square. R is equal to 5. That's how you get your radius, and then you can find out the arc length. Okay?
Okay.
So the question can be given in any form. Okay, next you said the third one. Sorry, the second one. This one.
Yes. The second one. Can I try?
Yeah. Yeah, try to do it.
How? For this question, would I have to convert radians to degrees?
No, you don't have to convert the radians to degrees. You can take the central angle. So what is the total angle of a circle? The total angle 360 degrees, right? So you can convert 360 degrees into radians. 360 degrees is 2 pi.
Okay, so that would be 180 degrees.
Which one?
The central angle?
No, central angle is always 360 degrees, the total angle of the circle. You have to find
It would be 120 degrees.
which one? This one?
Yes.
Now you don't need to convert it into degrees. You can, like if you feel more comfortable in degrees, you can convert it, but that will be an extra step for you. So yes, this is gonna be 120 degrees and your angle is 360 degrees, like the central angle. You have to find out that area of the sector formed by the central angle AOB. So if this is a circle and you have this angle AOB, so this is ABO, and here this angle is this 2 pi by 3, which is 120. So they are asking that this sector is what fraction? This sector is what fraction of the complete circle?
So wouldn't it just be a third?
Yes, exactly. All you have to do is you just have to find out that this angle is what fraction of the total angle. So all you have to do is just find out this fraction. That's going to be just 1/3.
Okay.
Okay, now okay, this one I think we discussed, right? Part A.
Yes.
Yeah, we discussed part A. And the next, do you want me to discuss part B? Did you try out part B? We have
I don't think. I think I actually skipped that. I don't think I did it. I think I accidentally skipped it.
Okay. The other ones, did you try these? This one?
Yes. For number 4,
Hmm.
I got 6.
6. Okay. And that means for this one?
K is equal to
Okay, this
6.
one. K, you got 6. And the second one, N?
N is equal to 81.
81. Okay, let me just quickly verify the answer. Okay, here the radius is 27. AB is an arc. This is 40. The length of the arc is k pi. So length of the arc will be 40 over 360, which is
1.
1 over 9 times 2 pi r. So 2 pi r. R is 27. So 27. This is equal to k pi. So this is 3. Shouldn't it be? Yeah. 3 times 2, k is 6. K is 6. That's correct. And the area of the sector is n pi. So again this is gonna be 1 over 9 times pi r square. So r square, that means 27 times 27, that is equal to n pi. Pi gets cancelled. This is 3, and 3 times 27 is 81. Yes, this is also correct. Okay, then try to also do the part B of this question, Anika. Okay, perimeter of.
Okay.
Now let's review the other assignments.
Okay.
First is equations of circles. Okay, so can you tell me your answers for first, second, third, and fourth? So this is, I've opened the equations of circles assignment.
Okay. So for the first one I got D,
Okay, that is correct.
and then the second one I got C,
Second, C is correct.
and then for the third one I got A.
A is correct.
For the first one I was stuck with B or D.
You mean for the fourth one?
Yes, 4.
Okay. So in the fourth one it says we have to find out the equation of the circle and the endpoints of the diameter are given. You are stuck with B or D, right?
Yes, because I tried using um the distance
The dis
formula,
hmm.
but whenever I used it, I kept getting like a value that wasn't anything like the answer. So I don't think I
Okay.
was using it the right way.
Okay, so you got the left hand side of the equation.
Hmm.
You got the center, but you are not able to get the radius as any value, like neither 50 or 25. Okay, so the radius will be, how did you find out the radius, Anika? Can you tell me your steps?
Um, well, I erased. But what I did was
Hmm.
that I I like plugged in the x and y values that I had into the distance formula.
Hmm.
So I did like negative 8 minus 2
Hmm.
uh, squared.
Yes.
So that's 100.
Hmm. So can you tell me what is it? What did you get after applying the distance formula?
I think I erased.
Did you get 100?
No, I think I erased it. But I
Okay.
think I got root 200.
Root 200. I think you should get 100. So can you
Okay.
right now, can you quickly do it? So let me do it here. See, a negative 8 minus 2 whole square, and then you have 4 minus negative 6 whole square. Is this what you did?
Yes.
Okay, so negative 8 minus 2 is negative 10. Negative 10 square is 100.
Mm-hmm.
Then 4 minus negative 6 is going to be 4 plus 6, and that is 10 again. 10 square is again 100. Okay, so that is correct. It is root under root 200. Okay, now what will be, can we simplify this? Square root of 100.
Could it be 100 times 2? So 10
1
root of 2?
100 times 2, so this is gonna be 10.
Root 2?
10 root 2. Perfect. So this right now is what? This is the distance between this point and this point.
Oh, and then I have to divide that by 2 in order
Yes,
to. Okay.
because this is what? This is the length of the diameter.
Okay, okay, yeah. So that's where I went wrong.
Yes, so what will be the radius? For that you divide this by 2. So divide 10 root 2 by 2, that is 5 root 2, and then on the right hand side you have r square. So what will be the square of this?
So wouldn't it be, wait. So 50?
50.
Because, oh, because 25 times 2.
Yes, 5 square is gonna be 25, and square of root 2 is gonna be 2. 25
So it
times 2, so
would be
it would be b. Okay,